In this video, we are going to do just a brief introduction of the topic present value. And so here at the top of the screen, I have for us the formula for the present value of an ordinary annuity, where PV stands for present value, PMT stands for a periodic payment, I is the interest rate per period, and N is the total number of compounding periods. We're going to work through just a basic example so that you have an idea of how this formula works. And as we do, just keep these things in mind. If the values for I and N aren't clearly stated, we're going to need to calculate those using the little mini formulas that I have here, where I equals the annual rate given as a decimal divided by the number of times per year that the money is compounded. And for N, if N is not explicitly stated, we're going to need to calculate that just by multiplying the number of times the money is compounded by the number of years that's given. The second thing to keep in mind that as we work problems related to present value, we will be careful to follow the order of operations. Also, use your calculator to compute with exponents if you're not sure how to do that. Consult your user manual for the calculator or ask your instructor. If you provide your instructor with the type of calculator that you're using, he or she should be able to guide you to the keystrokes that you need to use to compute with exponents. And finally, we won't round to the final answer. This is to ensure that we get the most accurate final answer possible. Alright, let's do our first example. Actually, we're going to do only one example in this video, so here it is. Use the present value formula to find the payment required given that the present value is $29,105, N equals 106, and I equals 0.025. So first thing I'm going to do is write the present value formula on my paper. Present value equals payment times the quantity, 1 minus 1 plus I to the negative n power in the numerator, all divided by I. And just to clarify, this little negative n in the exponent, that just means that we're going to take the opposite value of n that we're given. So we'll see how that works here in just one second. Okay, now that I've stated the present value formula on my paper, notice that in this particular example, we are given the values for N and we are given the value for I. So we don't have to do any mini calculations for those values. We can plug those straight into the formula. So let's go ahead and do that. Let's plug in the values that we know and we'll go from there. So the present value is $29,105. The payment is what we're trying to find, so I'm going to leave that as PMT. In brackets, I have 1 minus 1 plus I, which is equal to 0.025. For the exponent, negative n, another way that we can read that is the opposite of n. In this case, since n is 106, we're going to state our exponent as being negative 106. And then we're going to divide all that by I, which again is 0.025. So here we have a situation where we want to solve for payment, meaning that we want to get PMT on one side of the equal sign all by itself. The first thing I'm going to do in that venture is simplify this monster here on the right hand side, and I'm going to do that using the order of operations. So we have brackets on the outside, and on the inside we have this set of parentheses. Working from the inside out, I'm first going to simplify 1 plus 0.025, and I'm going to rewrite everything else. So as you probably know by doing many of these types of finance problems, when you simplify according to the order of operations, it's best to go one step at a time so that you don't make a goofy mistake. So 1 plus 0.025 is going to be 1.025. Again, that's raised to the negative 106 power, all divided by 0.025. Now that I've simplified that inner set of parentheses, I'm going to deal with that exponent. And as a reminder, use your calculator's exponent feature to calculate 1.025 to the negative 106 power. When I put that into my calculator, I get 0.072991165. Give myself a little bit more room here. Now I'm going to subtract 1 minus that decimal. Rewriting everything else though first. 1 minus 0.072991165. I get 0.9270088,395. And that's all divided by 0.025. Now we'll divide. When I divide this in my calculator, I get 37.080,35358. To solve for the payment, now I just need to divide both sides by this number, 37.080,35358. I'm going to divide the right side by that number, and I'm going to divide the left side by that number, 0.80,35358. On the right side, that cancels out, and that leaves me with just the payment, which was our goal. We wanted to get the payment all by itself on that right hand side. On the left side, when we divide 29,105 by 37.080,35358, that's going to give us the payment that we're after. So when you do that division, you should get $784.92. The payment is a dollar amount, and so I wrote it as a dollar amount, and as a rule of thumb, we will round dollar amounts to the nearest cent.